Hey, hi everyone. I hope everyone is doing well. So, coming after almost 8 to 10 days of break, I am covering one of another important system design individual component, and this is called rate limiters. So, you might have seen actually rate limiters in system design interviews can also be asked as question like design a rate limiter, and that is slightly different from the individual component of rate limiter. So where rate limiters as a system can also exist, where you have to full-fledgedly design a rate limiter, but this is more like an individual component, right? So again, covering few points on the introduction. I mean, it's a widely used individual component in distributed system pattern. uh, as the name suggests, it's used to kind of limit the resources that are, let's say, a user, a service, or a network server is trying to access over a period of time. It's primarily used to control the rate at which resources are accessed. Let's say, for example, you want to allow only a certain number of posts per minute, you want to allow only certain number of user authentications, right? Or you want to allow only certain number of queries in an hour, or couple of hours, or whatever time threshold that you have, right? Of course, rate limiters do allow for a lot of benefits, in your large scale application, whether it's a web or a mobile app. Resource optimization, for example, right? And prevention of overuse is definitely one of the biggest advantages. Um Cost reduction, yes, because, and I'll get into the details of how it is actually helping you reduce cost. Security of resources, because you are allowing certain kind of, let's say, automated, let's say you kind of automate a certain authentication mechanism, right? And you keep on basically trying to authenticate, uh, let's say, a particular user by just trying out all the username and password combinations again and again, right? So uh, if you have a rate limiter, you'll know that this is coming from an automated source, hence you block that source, right? So coming to applications of rate limiters, it might have extended in the recent years to not just web services and queries, but I think predominantly on web services. By far, the biggest chunk of rate limiters is found. They're often used to prevent overuse of web services, such as API endpoints, right? And DOS attacks is something, excess resource usage can happen when you have those in place, right? So uh, network traffic, of course, you can use to decongest, your network, prevention of overload on network trafficking side. But I think on network trafficking, you can always uh, try to increase, let's say, the hardware component, which is where I am linking it back to cost reduction. If you are hard pressed on cost, then rate limiters could probably be a better way of reducing the network, or controlling the network traffic, as opposed to, let's say, increasing the number of routers, or increasing the number of network servers, right? So cost is always a challenge. You have limited cost budgets to implement your infrastructure, so you have to keep these things in mind. Implementation of rate limiter is one that can help you reduce the cost. Database queries, again, I think, if you don't allow, I think, any sort of restriction on the number of queries a user or an application can perform, again within a certain time frame, right? Then you are going to overwhelm your database. You might be doing a lot of writes, right? Or you might be doing a lot of reads, depending on whether it's a read or write heavy, query system. It can basically just lock out, I think, the users, right? User authentication, again, I had mentioned that number of login attempts, for example, right? Uh, you know that you have a particular set of users, let's say 1,000 users that are trying to authenticate onto your application, and then if you try uh, to stop an abnormally high number, uh, that's an application of rate limiter. With that, you're also basically getting into the part where you know that 1,000 users, let's say on an average per user, 5 authentication attempts are allowed, right? So 5,000 basically overall, on an average daily authentication should come to you. If that 5,000 becomes 20,000, then you know that there is some sort of brute force attack that is happening, right? So you can rate limit and prevent such abuse as well. Simple, I think, diagram to help explain. I think, let's say users are trying to access service endpoints or databases, right? I mean, without a rate limiter, pretty much no control on how it happens, right? With rate limiters, of course, users can be redirected, and put, let's say, on hold on their request. We'll also look at how rate limiters implementation happens. But typically, let's say you have three users, Bob, Alice, and Eva. There is a rate limiter that is just allowing Eva to direct queries to other database, because let's say that is the limit that you have set, right? How do you set and all that? I think the technical implementation will get in the last part. But let's say Bob and Alice are also Bob, Alice, and Eva are also doing requests to the service endpoint, and there's some action that that service basically takes, right? So in this case, you are either allowing Bob or Alice, depending on the design, or you might allow both, but you are not allowing all three simultaneously, to reach this service endpoint, right? So it's kind of out of the maximum number of users that you have at any given point of time, you are allowing only a certain set of users to access your resources, right? So, how do you do that? I think yes, there are algorithms that are in place, like any uh, implementation of an individual component, right, in system. So, token bucket, I mean, rate limits are enforced basically, uh, and there is a bucket, as the name suggests. So you enforce rate limits, and the bucket is basically filled at a constant rate, and tokens are consumed when basically requests are made. And if the bucket is basically, let's say, empty, right, then the requests are kind of blocked out until the bucket is full. You won't pass any tokens, right? Leaky bucket, probably not used as much, but good to know from theoretical concept perspective. Algorithm is similar to token bucket, but basically allows some leeway on the rate limit. The rate limit is basically what you are allowing to pass through, right? So when here in this algorithm, in the leaky bucket algorithm, when the bucket is full, right, you can allow the access request, to pass. So you allow basically access requests to pass through a certain reduced rate. What you are doing in token bucket is, if the bucket was empty, the requests were blocked completely, or let's say delayed, right? So that is the difference, right? So here the bucket is full, access requests are allowed to pass through a certain rate. And here the bucket was empty, the requests are kind of blocked out. Uh, right? You're basically waiting for the bucket to be filled in the token bucket. And hierarchical rate limit allows for, I mean, you can use it as the name suggests, right? It's kind of like a tree structure wherein you have a application, you might have users, you might have different IP addresses, at different levels. So at each level, you can basically limit. So you might limit users at a certain layer, you might limit IP addresses at a certain layer, you might reduce or limit application usage at a certain layer, right? So that is how these algorithms are useful. One of the simplest and cleanest, I think, examples on implementation. Let's look at, I think, the token bucket implementation that we just discussed in the algorithm. So here, for example, you have a request, right? And you have a rate limiter in place. Uh, Basically, your request is entering the rate limiter, right? That's your first step. The request basically enters the rate limiter, and the next On the next this thing, the step is you're basically checking in the token bucket that to see if there are enough tokens available to process the request. Correct. Now, obviously, you can imagine that this bucket right here is filled at a constant rate because you're getting requests and rate limiter is kind of reducing or limiting the requests that can come in, right? So the token bucket is filled at a constant rate, and tokens are obviously passed from the bucket and consumed and probably passed on to your next system component, which could be, let's say, a front end endpoint, or whatever, like connecting, let's say, queue or whatever it is, right? Tokens are basically consumed when requests are made, right? So requests have to be made, and then finally, if let's say the token bucket gets empty, uh, this is where the implementation is referring to this token bucket algorithm. So if the token bucket is empty, the request is blocked or delayed until tokens become available. Correct. So you have to wait till your token bucket is kind of full, and only then you pass until tokens become available. Correct. So this is a straightforward implementation of rate limiters. Good to know. I think the concept from a design perspective um, might draw some similarities between load balancers as such, but understand that I think this is primarily used, as kind of an hard code limits that you want to set on your, starting from the starting layer, right? Which could be your mobile apps or web apps. uh, if I were to compare this to maybe, let's say, what we did in load balancers, so I think load balancers are also very similar in nature, but load balancers are primarily used, if you recollect from the lecture, right? Load balancers are primarily used to distribute the traffic and not as much as the request. Of course, the traffic can constitute of the request, but load balancers, are predominantly used to increase the capacity, right? If you recollect, and of course, we had looked at some of the, like, algorithms there as well. But I would say, like, uh, both of these components are essentially used, like load balancer as well as, like, your rate limiters are kind of trying to reduce the overall resource usage, trying to optimize the cost, trying to optimize overuse. Right, one is doing it at one particular level and the other is doing it at another level. So slight difference, I think, and in how these are also implemented and how different rate limiters and load balancers are. But I hope, I think you found this video to be useful, primarily from an understanding in the distributed system implementation and a large scale implementation via rate limiters used. So until the next video, keep watching the content, and keep learning. Uh, Bye for now.